Okay, so here we are in 1.7, and in the last video we learned about the precise definition of a limit. So here's the precise definition, what's sometimes called the epsilon delta definition. Let f be a function defined on some open interval that contains the number a, except possibly at a itself. So we're seeing this, graph on the x-axis about a. Then we say that the limit of f of x as x approaches a is L, and we write the limit as x approaches a of f of x equals L if for every number epsilon positive there's a delta positive, such that if positive absolute x minus a is less than delta, then absolute f of x minus L is less than epsilon. So example 1, use a graph to find a number delta such that if absolute x minus 1 is less than delta, then absolute value of the difference of the trinomial x cubed minus 5x plus 6 and 2, the absolute value of that is less than 0.2. In other words, find a number delta that corresponds to epsilon equals 0.2 in the definition of a limit for the function f of x equals x cubed minus 5x plus 6 with a equal to 1 and L equal to 2. So the limit as x approaches 1 of this trinomial function evidently is to be 2. Now, in the previous video we looked at an example. We didn't call it example 0 or example 1, but there was an example, and the function was not cubic like this one, it was linear. And there was an easy move to find the delta in terms of epsilon. I think delta was epsilon over 2. But here, it's not like that at all. Okay, so now we're going to use a graph to find the delta, so we will that will change things because we're just trying to find an approximation. So here's a graph of f. It's cubic, it looks cubic. We're interested in the region near the point 1, 2. And so this inequality, absolute f of x minus L less than epsilon, which is 0.2, we can write it this way. Okay, we can simplify the we can say, oh, let's put the negative 0.2 out here and add 2 to all three sides, and that would be the same thing as the absolute value statement. So we need to determine the values of x for which the values of x for which the curve y equals x cubed minus 5x plus 6 lies between the horizontal lines y equals 1.8 and y equals 2.2, in keeping with that compound inequality that we just saw, right? Which was 1.8 less than x cubed minus 5x plus 6, which by the way is not f, it's something else. Actually, it is f. Okay. Okay, so here's the graph. And, you know, this is y equals f of x right here. And so y is between 1.8 and 2.2. Well, what are the values of x for which that is true? Okay, well, they're going to be these values of x right here. Okay. There's the 0.12. So it's like, how close do we have to be to 1 to do that? How close do we have to be to 1 to do that? Well, it's going to be this distance here. We've got to make sure we're within that distance either way to get the job done. Then we use the cursor to estimate, or we could use the trace feature, or we could use the intersect feature, my favorite. Okay, find the x-coordinate of this point here. Find the x-coordinate of this point using the intersect feature. Second trace 5, enter, enter, enter. And then second trace 5, move the cursor left or right, enter, enter, enter. Then we use the cursor to estimate the x-coordinate of the point of intersection of the line y equals 2.2, that is that top horizontal line, and the curve. Okay, so again, there's our point of intersection. And doing that, we would get this number. It's about 0.911. Okay, that's what that x value is right there. Similarly, the other point of intersection, 1.124 is what that number is, x-coordinate of this point. So this is the point 1.124, 1.8. Rounding to be safe, we say that if x is in this interval from 0.92-ish to 1.12-ish, then function in the vertical is between these values, 1.8 and 2.2. This interval, though, is not symmetric about x equals 1. Right? Here's 1 right here. And there's more room to the right of it than there is to the left of it. The distance from x equals 1 to the left endpoint is about 0.08. But to the right, you have about 0.12. And so we're going to pick the smaller number. And that way we know if we're within 0.08 of 1, then the function will be between 1.8 and 2.2. Then we can rewrite our inequalities in terms of distances as follows. If the distance from x to 1 is 0.08, then the distance from the function, the curve, to 2 is less than 0.2. This just says that by keeping x within 0.08 of 1, okay, we keep x within 0.08 of 1, we are definitely going to keep f of x within 0.2 of 2 in the vertical. Okay, so we'll definitely keep f of x in here. Although we chose delta equals 0.08, any smaller positive value of delta would also have worked. I mean, we could have given a kind of a cheesy answer and said, oh, let's let it be 0.01, okay, in either direction. Yeah, that'll keep the function within a distance of 0.2 from 2, right? I mean, then we would just be talking about this much, and that's definitely within 0.2. In fact, it's a lot less than that. Okay, so this is using a graph to make an argument about a delta. Now, in the next video, we'll talk about how to reason not from a graph.